Hey everybody, welcome back to the channel. So Bill Ackman is one of the most famous money managers on Wall Street. Currently, he has about $16.5 billion assets under management, and he owns only 5 to 6 stocks. He doesn't own a lot of companies. However, over the weekend, I was looking at some of the companies that Pershing Square, which is the name of his asset firm, owns, and I came across something very interesting that has to go back to Palantir. Now, Bill Ackman doesn't own Palantir. That's not really the type of company he would own. But he does own Chipotle, very famous for getting Chipotle correct, 4.5% of the portfolio. Alphabet, this is a new stake that they've been heavily piling into, 4.1%. Hilton, Lowe's, Universal Music Group, Restaurant Brands, Canadian Pacific, Kansas City Limited, and then they have a bunch of share buybacks, bonds, cash, etc. That last company, Canadian Pacific Kansas City Limited. That's CPKC for those that don't know. And the reason that that got my attention is because this is the company that presented at Palantir's AIPCon. This is one of the largest railroads across Canada, the United States, and New Mexico. And it's a pretty big company in terms of the things they have to do, the operations they go with. And I was going to react to their presentation at AIPCon anyway, but then I looked into how Bill Ackman owns the stock as one of the 5 stocks he owns in his entire portfolio. And I thought, well, that's really interesting for Bill Ackman, who's a very famous money manager, to be owning a company that is now using Palantir's AIP. So in this video, if you've watched it already, I would recommend watching the presentation again while I'm reacting to it, because it just deepens your understanding of Palantir and AIP. And if you haven't seen this presentation, this is one of the spokespeople, I believe is an executive VP at the company, presenting at AIPCon. And he goes through and explains how they're leveraging AIP and Foundry in a meaningful way. And it was one of the more interesting presentations. I think the Eaton presentation, the HCA and CPKC were the best presentations. Eaton was like the most clear in terms of understanding the stuff. HCA with healthcare was just, amazing. This stuff is very unique because it's a railroad company. And the challenges that railroad companies face are obviously very different than regular companies. So let's hear how they're leveraging Palantir's AIP, why it's important for them, and ultimately what they're going to be able to do to use Palantir's AIP in a more meaningful way. Let me just reduce myself right here. Okay, here we go. And hopefully it gives us some context for why Bill Ackman owns them as one of the 5 stocks in his entire portfolio.
The power of the framework and the power of accessibility of this framework. Remember these 2 words? These are not prepared. That's what I'm learning today. Okay, I'm Shailesh Sharam. Yes, you heard right. I manage the business intelligence, which is innovation, as well as cybersecurity, which is governance and risk management. I'm from CPKC. On April 14th, we marked an iconic day of merging 2 big, giant historical railroads together, that is Legacy CP and Legacy Kansas City Southern. We now operate, or the only single-line railway operating in Canada, US, and Mexico, with 20,000 miles of network. What we're going to talk about today, again, very briefly, we built a solution around network management, and potentially the biggest users is service designers. Before jumping into what we are trying to do, how many of you wondered seeing a train pass by and thought about where are the cars coming from and going to? And imagine someone is wondering about 80,000 such cars every day. 80,000 such cars, with 3,000 stations, 5,000 customers day in and day out. And there is a method to madness, and we call it precision scheduled railroading. That is a power all the railroads use. I have my fellow railroaders here. We have a love and hate relationship. Don't find any faults, please. Okay.
He was talking about railroad companies that are competitors that are in the audience that were there, I'm assuming, to procure AIP or to look into it. And so they're looking at this presentation. But what he's talking about is, 5,000 different schedule places you have to, 5,000 customers, 3,000 scheduled stations. There's so many different things you have to optimize to be able to have a railroad conduct effectively. And so there's a wealth of data you have to make sense of, and that's why he's here to show what AIP is doing for them.
So the architects of this service, of this precision scheduled railroading starts at the design. We have a design how to run the trains. They create order in this chaotic world by giving a unique mission for every car, 1 car at a time. Where does it start? Where does it go? Which route it takes? What is the best possible way to run the railroad serving the customer with the minimal cost. Sounds so simple, right? So, so there are a lot of metrics, a lot of measures which go into the mix, and some are publicly disclosed, some are internally monitored.
You can see the problem here is congestion at a railroad causes all processing to take longer, which is called rail car dwell, increasing the congestion even further. In extreme cases, it escalates into a meltdown, which can cost millions of dollars. The approach they're using with Foundry and AIP is an interactive tool for service designers and operators to forecast, dwell, and problem solve iteratively, which means in real time based on different issues, and incorporate LLMs, forecasting models, optimization, and scenario analysis. And what he's going to take you through is an example of how they were to use AIP in case something were to happen.
We are going to talk about one such problem of managing dwell. Again, in a simple terms, dwell is how much time a car is spending in a yard. Yes, it is supposed to spend time, but how much is it planned versus actual? What makes this problem complex is if you're not managing the dwell, if you're not managing the volume of incoming cars into your station, right, you're not only impacting the cost and performance of your station, but you're also going to impact the incoming trains and outgoing trains, thereby entire network. And this is an age-old problem. Frankly, every railroad has this problem, and it has been the standard optimization problem for any logistics company: first mile, last mile, yard management, plant management. One day, that's what innovators are promising us, that there is quantum computing out there. All we have to do is throw the data, it'll give us what to do. I think it's 10 years, 15 years ahead of us for sure.
What he's saying is the problem with railroads is so complex in terms of what they have to manage, all the data that is involved, and trying to actually get an answer, that the innovators are telling us quantum computing is going to solve that issue when you throw problems at that, but he believes that's not going to happen. I think they think LLMs are a V1, right? A version 1 of what quantum computing could be, because you throw a ton of stuff at it and you might get an answer. Maybe it's not the perfect answer that a quantum computer could give, but that's why the technology is so powerful, because if you can get somewhat of an answer for a problem that is very complex, it can make the life of these service designers and operators a lot easier.
What we're doing now is, again, stealing the words, AI-powered decision support system. We are not trying to recreate the world, means eating the entire apple, but chunks at a time, taking one problem at a time, take our data, forecast what's going to happen proactively, and give power to the user to make informed decisions. So we are using the Palantir platform to attempt it. So the challenges, as I mentioned, is it's a multivariate statistics problem, typical OR, operations research problem, and every logistics company is different. On top of that, every railroad is different. We run with different principles, different geographies, and different traffic mix. But coming to IT, the biggest challenge is how do we connect business to the models? What I mean is, how do we encode the business knowledge? Not only one time when we build the applications, but incrementally as the business changes and evolves. The second problem, and the toughest problem, I think someone already spoke today, is how do we get those models to business? How do we let them adopt and adapt to these technologies and trust them and not make the technologies obsolete? We hope we have found a formula to do that. We have done it in various ways in technologies, and this is another attempt, and I believe we cracked the formula this time. So we love maps, railroaders, all the railroaders. So here we have our CPKC network in 3 countries, and we already loaded our data into our ontology, 10 years of history. We have a forecasting model running on the same platform telling 5 days to 14 days out where could be the potential problems. And these are all the alerts, and a user, whether it is service design user or an operations user, can proactively see what could happen 3 days from now. And again, there is a math and science to it. Math is you have something coming your way, all you're saying is when is it coming. Science is how do you put external factors in? How do your historical performance in? How do you say what happened when there is a snowstorm in the east? How is it going to impact the west? I think all those models are running in the background to give this prediction. I'm not going to show that today. Assume we are starting with the alert, and this is Aelith, a station near Calgary, one of our key junction coming into the west.
So what he's going to show here is a problem that happens to one of their key stations in Calgary, in Canada, and how, theoretically, this is all fake data, AIP would react if they had a problem like this.
So what we can do here is we can zoom in and exactly find out what's happening at Aelith and what is the alert saying. In a nutshell, you have some numbers there. what is the average dwell, what is leading to the alert. It is 44.2 hours it is predicting. Again, it is notional data. Please do not tell any analyst on anything. We are all perfect. Okay. So what we're doing is, okay, no one, executives or decision makers wants to know what is truth behind it. So we give the trend, and there are a bunch of screens which are not visible in the video, but historical actual volumes and historical actual dwells, so that they can link back to operations. And then the next question is, how do I address and solve this dwell proactively? And remember, this is all 2 days out or 3 days out. So the traffic is already en route to you. It's not that you can't stop the traffic. Some of it is already coming. Some of it customers are about to release. So what we ask in the next step is the co-pilot, agent, whatever we call, but the AI agent to say, can you find a solution to me? And this is where the magic is. As I think Brian spoke, we already included some intelligence. We're asking some questions. Build a plan to reduce dwell ALith. And let it run. And it is computing. But what is critical here is we have not loaded our entire intelligence yet. We have loaded some of the levers which we have in control while the traffic is en route to reduce the dwell. So with the knowledge we shared into the bot, it has come up with a plan. Again, it has 2 steps. Build a bypass block and hold a train. In a nutshell, the first step is saying, make sure the traffic is not getting worked in this station. Do the work ahead of time. Second point is saying that, okay, there is a train which is about to start 800 miles away. Stop that for 14 hours so that I can clear my yard and make smooth operations. I might like it, I might not like it. But the difference here is, whether it is a new service design user or an experienced operator, you're already coding the core fundamental business metrics into it. Whether he looks at it or not, whether he or she chooses to acknowledge it or not, we are showing the local impacts as well as the global network level impacts. That is the power of AI. When people say that it is going to pre-calculate and share it with you, it's up to the human. And
so this is sort of the core stuff I'm getting from the presentation in terms of why it's so valuable. The idea that you can say, hey, here's the problem, and then you can literally type in, how do I solve the problem? And it gives you different routes of action. 1, you do this. 2, you do this. And none of those answers have to be perfect, but the idea that a service operator who's trying to solve a really complex problem can ask an AI tool what to do and continue the conversation with that AI tool, that's where I think all the value is there. And again, these tools can't have hallucinations because this is real stuff going on at a railroad, right? So it can't say a number that's wrong. And that comes down to the question of how do you train the LLMs, which goes into the kind of K LLMs Sean was talking about in his presentation. But all of this stuff is conducted via the AI infrastructure that is AIP, combined with Foundry and the ontology of all your data. That in and of itself, to me, is incredibly valuable for a company like CPKC. The question is, what is it worth business-wise? And if it's integrated throughout the entire fabric of your organization, it's probably worth, a decent chunk of money. And if Palantir is able to just embed themselves within a lot of these organizations, that's where I see the real business opportunity with AIP.
Next step is, I think, we like the model or we don't like the plan, what it is building. And we are trying to simulate, yes, show me the results of your plan. It showed that, okay, the dwell is reduced by 2 hours, but it is comparing the base scenario with the new scenario put in, and it is showing the metrics so that we can challenge what is the cost. We are only showing 2 metrics or 3 metrics here, but eventually imagine you're showing the cost metrics, operations metrics, as well as the commercial metrics to it. So the next step what we built is good. We have one suggestion. We choose to take it or ignore it. But we are saying, what is the impact of this decision overall? And here there is a complex chart, too small to read. In a simple nutshell, on the left side, you have all the stations which these trains or the suggestions are going through. Each blue block is an amount of work. What it is telling me is, at the St. Paul, it has 3 yellow boxes. And those 3 yellow boxes are extra work someone else is doing to help me recover from my traffic congestion. And I saw the summary of it. Basically, it is saying you have to build 2 more blocks. Blocks is nothing but a group of 10 cars, 40 cars, or 100 cars, sometimes if it is a unit train. But I know as an experienced railroader, St. Paul is critical. I cannot put more work at St. Paul. So I can go back to the co-pilot and challenge, what can you do by ignoring St. Paul and by not giving more work to St. Paul? So that's what we're going to do here. I think I skipped it. So, okay. So we put another constraint. I think the key here is, I can repeat it again and again, but the model has been trained by pre-existing levers, but now you're also taking real-time information from the operator and including it in the modeling and scenario. But it's not only one time. You're capturing what was the problem, what was the user doing, and what kind of scenarios he's running with it, and what was the result of it. All of it is stored back into the ontology, into the knowledge base, where we can, or whether the same person or a different person can refer back to, and this is what is called building the knowledge base for the future. And then we know exactly which levers are impacting, how much they are impacting, what is model-driven versus what is operator-driven, what is data-driven technologies. So now we regenerated another solution. It is simulating, and we are also saying, what if I threw in more crews and more locomotives? We added this third scenario just to explain adding more crews and adding more locomotives is nothing but adding more cost. That is the last option we want to choose as railroaders is, again, PSR is run an optimal railroad with all the optimal resources. So if you're adding more crews, more resources, it might be beneficial only for certain points, but not all the time. So the model goes back, calculates, and shares with you the cost impacts as well as the operational impacts of the decision. And imagine you ran 3 scenarios in a nutshell, and the end user is able to say what are the results of each scenario, but not only for once. All the scenarios, all the results are stored forever for this metric, for this particular station. All I have to do it for 2,000 more stations across North America. And each station is unique, and each journey is unique, and we are embarking on a journey. It's not a one-time solution, but we are encoding intelligence piece by piece into this process.
Now, what you see at the end here, when they're saying we have an unprecedented power in combining a digital twin with our LLMs and having a broader transformation, is that the LLMs are getting stronger every single time. The reason being, now that you have all these things happening on a day-to-day basis, it's not just leveraging the 10 years of historical data to be able to give the model the knowledge repository to try to spit out answers, but now every day if something happens at this station or this station and you ask, hey, how do we solve this thing? And it says, here's the things. And you say, well, I don't like the solution. How do we solve this thing? All of that data, day by day by day, is going into the ontology, which is then training the LLM, which is then giving you even better answers on a day-by-day basis. This is a piece of software that the company will never not use. 50 years, 100 years of data, if a company is around that long, will be able to be stored, understood, synthesized, and then extracted value from as you ask the LLM questions, and that will only make the LLM better and better and better because it will know how to answer and give you better answers at scale. So that's why I think this presentation was so important, because CPKC is not a typical company, right? Like it's a very complex company in terms of the operations that they're handling every day. And them being able to use Palantir's AIP and really seeing a broader transformation in their entire enterprise as a result of the software is one of the ways that a company like them is going to be able to leverage AI, in particular Palantir's AIP. On top of that, it makes sense why Bill Ackman owns them, right? He tends to own these types of companies that have these types of moats that are really rooted in, I would argue, leverage and power. And when you're a railroad that connects between Canada, United States, and Mexico, that seems to show a lot of leverage and power in terms of what you'd be able to do. That's why I think he has Lowe's and Hilton Hotels and Chipotle, and now obviously Google. But it's interesting that he owns them, and they're trying to be a cutting edge railroad company, not a legacy railroad company, by upgrading their IT to a brand new paradigm of how they even think about artificial intelligence and data-driven decision making. Super exciting stuff. CPKC, I watched this presentation like 3 times, so I think I have a good understanding of it, and I hope to see a lot more presentations in the future for how companies are leveraging Palantir's AIP. Thank you guys so much for listening and watching. I will see you in the next one.